Right now, you are probably listening to this deep dive on some kind of computerized
Or
device.
maybe you're, waiting to ride a city bus later
Yeah.
today.
Yeah, or you almost certainly checked a weather forecast this morning. And you probably made at least one decision today based on weighing risks and rewards.
Right, which means you are navigating a world designed, in large part, by a 17th century French genius named Blaise Pascal.
But what you probably don't know is that this pioneering scientist, I mean, the man who basically laid the groundwork for modern computing and probability, well, he spent the last years of his life wearing a coat with a frantic, secret, mystical manifesto sewn tightly into the lining.
It is a profoundly weird contradiction, honestly. We're taking a comprehensive encyclopedic look at Pascal's life today. And the mission here is to figure out how one brain could hold all of these seemingly opposing forces.
Exactly. We want to uncover how a single mind could simultaneously pioneer computer engineering, map the mathematical laws of the future, completely redefine the scientific method,
And yet craft some of history's most enduring philosophical defenses of pure, uncalculated faith.
it's just wild. We are looking at someone who only lived to be 39 years old, but he left fingerprints on almost every aspect of modern life. So, to understand how his unique brain was wired, we have to look at his unprompted, almost relentless drive to pull order out of chaos.
Which started incredibly early, by the way. Pascal was born in France in 1623. His mother passed away when he was 3, so he was educated entirely by his father, Etienne.
And Etienne was a tax collector, right?
Yeah, a tax collector with some very unconventional educational theories. He actually forbade young Blaise from studying mathematics.
Yeah.
He believed the boy should master Latin and Greek first before his mind was, corrupted by numbers.
Which, if you know literally anything about human psychology, is the absolute best way to guarantee your child becomes completely obsessed with mathematics.
Oh, it backfired spectacularly. At age 12, completely on his own without any textbooks, young Blaise was found on the floor with a piece of charcoal, drawing geometric shapes on the tiles,
Just figuring it out from scratch.
completely from scratch. He had independently deduced and reconstructed Euclid's first 32 geometric propositions.
Wow.
And he didn't even know the proper terms. He called circles rounds and lines bars. He was just logically figuring out the foundational architecture of reality for fun.
Okay, let's unpack this, because
Sure.
that level of innate structural thinking didn't just stop at charcoal drawings. By 16, he wrote a treatise called The Essay on Conics.
Which was a massive deal.
Right. It was so precociously brilliant that René Descartes, who was arguably the most famous philosopher and mathematician of the era, flat out refused to believe a teenager wrote it.
He publicly insisted that Etienne must have authored it to make his son look like a prodigy. Descartes was basically calling them frauds.
But humiliating Descartes wasn't enough for young Pascal. At age 19, he looks at his father, who is now the tax commissioner for the city of Rouen, manually calculating endless columns of tax records late into the night.
Which is just exhausting, chaotic work.
Exactly. So Blaise decides to build a machine to do the thinking for him.
He invents the Pascaline, which is one of the world's first mechanical calculators. And it is crucial to understand the mechanism here to grasp why this was such a monumental leap forward.
Because before this, math was just in your head.
Right. Up until this point, arithmetic was viewed purely as cognitive labor. It happened in the mind. Pascal figured out how to physically embody a mathematical concept.
He mechanized the carryover.
He did. He engineered a series of interconnected brass dials. If you dial a 9 on the ones column and then added one more, the dial would click past 9 back to 0.
Like an odometer in a car.
Exactly like that. As it did, a tiny mechanical lever would catch and physically push the adjacent tens dial forward by exactly one notch. He proved that human logical thought could be outsourced to a physical machine.
Wait, so he essentially built the first hardware startup. He creates this brilliant, pioneering piece of tech to solve a real-world problem, but the production costs are astronomical, right?
So,
Completely out of control. He makes about 50 prototypes, iterates obsessively, and finally builds 20 finished machines over a decade.
and it completely fails commercially because it's too cumbersome and wildly expensive for the average clerk to actually buy.
It basically became 17th century vaporware.
Exactly. It turned into a status symbol for the ultra-rich. I think he even gifted one to the Queen of Sweden.
He did, yeah.
It's the classic Silicon Valley hardware launch. Overhyped, beautifully engineered, and totally impractical for the market at the time.
But the underlying concept proved that human cognitive labor could be mechanized, which laid the bedrock for 400 years of computer engineering.
And he didn't stop at mechanizing arithmetic. He took that same rigorous mechanical logic and applied it to the invisible physical world.
Which brings us to the whole vacuum debate.
Right. At the time, the prevailing scientific dogma, handed down from Aristotle, was that nature abhors a vacuum. The entire scientific establishment believed that empty space was a physical impossibility. They thought the universe had to be completely filled with invisible matter, a concept known as a plenum.
But Pascal hears about experiments happening in Italy with barometers. These glass tubes filled with mercury turned upside down into a bowl. The mercury drops down the tube, but stops, leaving a weird empty space at the top.
And the Aristotelians claimed that space was filled with invisible vapors because, again, a vacuum was impossible.
Pascal looks at this and realizes that if he can prove that space is truly empty, he shatters centuries of established scientific dogma.
He hypothesizes that the mercury isn't being held up by some mystical aversion to a vacuum, but by simple mechanical weight.
Just gravity and pressure.
Right. He theorizes that the invisible atmosphere of the Earth actually has weight, and the air pressing down on the bowl of mercury is what pushes the liquid up the tube.
Which leads to one of the most hilariously tyrannical experiments in the history of science.
It really is.
Pascal reasons that if the atmosphere has weight, it must have a roof, a maximum height. Therefore, if you carry a barometer up a mountain, there should be less air above you pressing down, and the mercury inside the tube should drop.
But Pascal's health is notoriously fragile. He suffers from terrible chronic pain and literally cannot climb a mountain.
So he relentlessly prods his brother-in-law, Florian Perrier, for months. He essentially bullies Florian into hiking up the Puy de Dôme, which is this massive volcano in central France, carrying these delicate glass tubes of quicksilver.
Florian finally gives in and does it in 1648. He takes measurements at the bottom, the middle, and the peak of the mountain.
And the results?
Undeniable. The higher he climbed, the lower the mercury dropped. Pascal had proven that the Earth's atmosphere was finite and that the vacuum was real.
Here's where it gets really interesting, though, because the fallout from that mountain hike wasn't just about air pressure. It fundamentally changed how we define truth.
Yeah, what's fascinating here is how Pascal codified the rules of engagement for science itself. In defending his vacuum theory against furious critics, Pascal laid down a strict, uncompromising definition of the scientific method.
He wasn't messing around.
Not at all. He stated that it doesn't matter how beautiful, ancient, or logical a theory seems. If a hypothesis leads to something contrary to even a single observable phenomenon, that one data point is enough to prove the entire theory false.
It's the absolute standard of falsifiability. One bad piece of data kills the theory. And you, listening, rely on this every time you step onto an airplane or take a prescription medication.
You are trusting systems built on Pascal's ruthless demand that nature must speak for itself, overriding any human assumption.
But he doesn't stop with the physical atmosphere. He takes this obsession with calculating reality and points it at something entirely intangible, which is the future.
The birth of probability.
Yes. So in 1654, a friend of his, the Chevalier de Marais, comes to him with a problem.
The de Marais is a writer, a philosopher, and a high-stakes gambler.
A fun combination. And he presents Pascal with this puzzle. He asks, if two players are in the middle of a game of chance and the game is abruptly interrupted, how do you fairly divide the stakes based on the current score?
Which is tricky. You can't just split it 50-50, because one player was probably winning.
Right. But you also can't give it all to the current leader because the trailing player still had a mathematical chance of a comeback.
So Pascal starts writing letters to another brilliant mathematician, Pierre de Fermat. And in this correspondence, they map out the exact mathematical mechanics of chance. They invent the concept of expected value.
Okay, let's break down how that actually works, because this is the invisible math running our modern lives. How do we explain expected value?
Well, expected value is essentially a formula that multiplies the probability of a specific event happening by the potential payout if it does happen.
Okay, give me an example.
Say you are rolling a standard six-sided die. If you roll a 6, you win $60. The probability of rolling a 6 is 1 in 6. So you multiply $60 by 1/6.
Which means the expected value of that single roll is $10.
Exactly. So if the casino charges you $15 to play that game, You can mathematically prove it is a losing bet over time, even if you don't know the outcome of the very next roll.
It's like a mathematical crystal ball. I mean, it doesn't tell you exactly what will happen tomorrow, but it gives a precise numerical weight to uncertainty.
Which was revolutionary.
Think about that for a second. Before these letters between Pascal and Fermat, the future was the domain of fate, or luck, or just the divine. It was inherently unmappable.
But Pascal took the unknown future and mathematically commodified it. Every time you buy auto insurance, your premium is calculated using expected value.
Right. The insurance company knows exactly how to price your policy because they have mathematically quantified the risk of you crashing.
This completely rewrote the operating logic of human decision-making. Economics, sociology, meteorology, high finance of the game, all of it relies on the groundwork laid by Pascal and Fermat figuring out how to fairly settle a 17th century dice game.
So if we pause here and look at the scoreboard, Pascal has mechanized human thought with the calculator. He has quantified the invisible atmosphere. He has mapped the unwritten future.
He is the ultimate rationalist.
Exactly. Operating at the absolute peak of scientific triumph. He can calculate anything. And then he hits a wall that refuses to be quantified.
The messy, unpredictable reality of human frailty, family drama, and mortality.
It starts with his father slipping on an icy Parisian street and breaking his hip.
Which, in the 1600s, a shattered hip in a man that age is basically a death sentence.
But they managed to hire two incredibly skilled doctors who move into their home and actually save Etienne's life. But these doctors aren't just medical men, are they?
No, they belong to a splinter movement within Catholicism known as Jansenism.
Okay, and what is Jansenism exactly?
Jansenism was a deeply severe, rigorous, and austere form of faith. It emphasized original sin, human depravity, and the absolute necessity of divine grace over human action.
Very heavy stuff.
Very. And during the months these doctors are living in the Pascal home, they're having deep philosophical debates with Blaise. He experiences what biographers call his first conversion.
He's deeply moved by it.
He is, though he eventually pulls away back into his worldly life.
But the philosophical seed is planted, and it blooms during a massive family crisis shortly after. Etienne dies, and Blaise's sister, Jacqueline, decides she wants to leave the world behind and become a nun at the strict Jansenist convent of Port Royal.
And Blaise feels completely abandoned. His own health is terrible. He really relies on her, and he actually fights her on this.
Yeah, he bitterly withholds her portion of the inheritance for a period before finally relenting. So now he is left alone in Paris, leading the life of a wealthy, highly respected secular genius, but he's deeply unmoored.
Which brings us to the night of November 23, 1654. The memorial.
Oh man, this is where it gets crazy. Between 10:30 and 12:30 at night, Pascal has an intense, violent, completely unexplainable mystical experience.
We don't know the exact trigger, but we know the result. He grabs a scrap of parchment and frantically writes down what he's feeling.
It's this jagged, poetic document. It starts simply with the word fire, and then he writes, God of Abraham, God of Isaac, God of Jacob, not of the philosophers and the scholars.
And then he does something so bizarre. He takes this piece of paper, sews it tightly into the lining of his coat, right over his heart.
And he kept it there forever.
Yes. Every time he gets a new piece of clothing, he meticulously unstitches the note and sews it into the new garment. He never speaks of it to anyone. It was only discovered by a servant after his death.
It's incredible. He practically turns his back on his scientific peers after this. This man, who demanded rigid empirical data for the vacuum, completely abandons the scientific pursuit of the divine.
He embraces a concept called fideism, which is the belief that human reason is too broken, too corrupt to ever understand God.
He actually writes, I cannot forgive Descartes. He accuses Descartes of just using God as a philosophical tool to wind up the clockwork of the universe and then just discarding him.
Pascal believed that if God could be understood by a mathematical proof, that God wasn't worth worshiping.
So he essentially moves into the Jansenist community at Port Royal and pivots his towering intellect toward literature and theology.
He writes the provincial letters under a pseudonym, deploying devastating, brilliant satire to expose the moral laxity and logical loopholes of the Jesuit order.
I read that the writing is so sharp, so popular, that it actually influences later Enlightenment thinkers like Voltaire and Rousseau.
Oh, absolutely. King Louis XIV is so enraged by it that he orders the book to be shredded and burned in public.
Wow. And around this time, he also begins compiling notes for a massive defense of the Christian faith, which would eventually be published posthumously as the Pensées.
This is where we get his Beautiful, tragic view of humanity. He wrote, "Man is only a reed, the weakest in nature, but he is a thinking reed."
So, what does this all mean? Because I'm looking at a staggering contradiction here. Pascal explicitly states that human reason is completely useless for finding God. But then he turns around and creates his most famous philosophical argument, Pascal's wager.
Right.
And what is the wager? It's his own mathematical invention. He uses probability and expected value to justify belief in God. How does a mystic who demands pure faith write a casino formula for salvation?
Well, if we connect this to the bigger picture, it is not a contradiction at all.
Yeah.
It is actually a brilliant piece of psychological warfare.
Psychological warfare.
How so? You have to remember his audience. He wasn't writing the wager for believers. He was writing it for his sophisticated, hyper-rational gambling friends back in Paris.
Ah, the secular intellectual.
Exactly. People who followed strict stoicism, trying to conquer all emotion with logic, or skeptics who doubted everything. Pascal knew you couldn't calculate your way into heaven.
So the wager isn't a proof of God.
Not at all. It is a rhetorical trap. He applies the exact mechanism of expected value we discussed earlier.
Okay, walk me through the trap.
He tells his skeptical friends, let's assume reason can never prove God exists. You still have to place a bet with your life. If you bet that God exists and you are right, the payout is infinite eternal life.
Right?
If you bet God exists and you're wrong, you lose a little bit of earthly pleasure, a finite loss.
Oh, wow. I see the math now. Even if the probability of God existing is incredibly small, say 0.0001%, if you multiply that tiny probability by an infinite payout, the expected value is still mathematically infinite.
Exactly. The logic dictates that betting against God is a mathematically irrational wager, because the potential loss is infinite and the potential gain is finite.
He used their own math against them.
Pascal was using the unbelievers' beloved logic against them. He wanted to corner the rationalists, forcing them to run the numbers and realize their worldview was a losing bet.
He wanted to induce such intellectual despair that they would have no choice but to drop their pride and seek grace.
It is a complete intellectual ambush.
He uses the cold machinery of probability to bankrupt human arrogance. I love that. Which brings us to the final, gritty chapter of his life. We move from these soaring theological heights right back down to the dirty streets of Paris.
Because he adopts severe asceticism.
Yeah, he decides he must deprive himself of worldly comforts. He famously claims that sickness is the natural state of Christians.
And he was certainly living that reality. His health was failing rapidly, but his brain simply would not shut off. In 1658, he is suffering from an agonizing toothache.
And suddenly the pain just vanishes.
Right.
And because he is Pascal, he doesn't just take an aspirin and go to sleep. He interprets the sudden lack of pain as a direct heavenly green light from God that he is allowed to engage in mathematics again.
So he dives right back into it. He tackles an incredibly complex geometric problem regarding the cycloid curve, even hosting a mathematical contest across Europe with actual Spanish doubloons as the prize.
Which is eccentric, certainly. But it's his final project, completed in 1662, right before his death at age 39, that truly reconciles the two halves of his life, the soaring intellect and the gritty human reality.
You mean the city bus?
He invents the city bus.
The carrosse sans sol.
Yes. It is the world's first modern public transportation system. He designs a network of carriages in Paris with fixed routes.
And a fixed price of exactly 5 sols.
And most importantly, the carriages departed on a strict schedule, even if they were completely empty. That is exactly the logistical mechanism of modern mass transit.
It really is.
But how do we reconcile this? The ascetic mystic who wore a secret religious manifesto in his coat spends his dying days working as a municipal transit planner.
This raises an important question about how knowledge should be used. The poet T.S. Eliot summarized Pascal beautifully, calling him a man of the world among ascetics and an ascetic among men of the world.
That's a great quote.
Pascal didn't build the transit system to get rich or to show off to the Queen of Sweden like he did with the past line. He did it to serve the poor.
He applied the genius.
He believed that knowledge and mechanical invention were deeply hollow if they only existed as abstract theory or toys for the wealthy.
He saw the working poor of Paris struggling to navigate a massive, sprawling city.
Providing a cheap, reliable, structured way for them to move and work was, in Pascal's eyes, a profound act of Christian charity. He used his supreme ability to organize chaos, to ease everyday human suffering.
And he passed away shortly after the transit system launched. An autopsy later revealed severe damage to his stomach, abdomen, and brain, which likely explained the agonizing pain he suffered his entire life.
His last recorded words were, "May God never abandon me."
Yet, looking at the world today, it's clear humanity never abandoned him. I mean, the SI unit of pressure you check in your car tires is named the Pascal. There is a major programming language named after him.
The microarchitecture that powered NVIDIA graphics cards a few years ago, also Pascal.
There's even a pacifist robot in the video game Nier, automata named Pascal, and an otter in Animal Crossing.
His legacy seeped into the very bedrock of our culture.
So, when you are standing at a bus stop, checking the weather app on your phone, and weighing the expected value of whether or not to carry an umbrella, you are living in the world Blaise Pascal built. He built the machines, he mapped the odds, and yet he ultimately surrendered to the one thing he couldn't measure.
And as we close this deep dive, I want to leave you with one final thought, returning to Pascal's ruthless definition of the scientific method.
The falsifiability standard.
Exactly. He argued that no matter how much data supports your theory, a single contrary phenomenon is enough to completely falsify it. In today's era of algorithmic information overload, where we are constantly fed data perfectly curated to confirm what we already believe, are you willing to actively search for the one piece of evidence that could prove your own most cherished assumptions wrong?
That is a brilliant, uncomfortable question to carry with you today. Thank you for joining us on this deep dive into the beautifully conflicted mind of Blaise Pascal. Keep questioning the world around you, and we'll catch you next time.